Our aspiration to augment and improve every aspect of business and life with data demands a paradigm shift in how we manage data at scale. While the technology advances of the past decade have addressed the scale of volume of data and data processing compute, they have failed to address scale in other dimensions. The changes in the data landscape, the proliferation of sources of data, the diversity of data use cases and users, and the speed of response to change. Data mesh addresses these dimensions, founded in four principles: domain oriented decentralized data ownership and architecture, data as a product, self service data infrastructure as a platform, and federated computational governance. Each principle drives a new logical view of the technical architecture and organizational structure. See, data management strategies are always evolving, and enterprises must be ready to adapt to such change to stay competitive via timely and reliably delivered insights. The data warehouse paradigm dates back to the 1980s. Back then, the organizations needed a centralized data platform for integrating data from multiple sources, such as mainframes and operational systems, and extracting insights from it. By the 2000s, data warehouse solutions had become fixtures of what were then still often called business intelligence operations. Over time, data warehousing also catalyzed the development of complementary data architectures, most notably the data lake and more recently the hybrid data lakehouse. These alternatives are now often used alongside data warehouses. But one of the most profound evolutions of enterprise data is the data mesh, which becomes a prominent trend starting in late 2020. The data mesh architecture has emerged to address the following key data management principles. First, a single source of truth is a must, but it's incredibly challenging when data is scattered among hundreds of disparate legacy, cloud, and hybrid systems. Second, the volume of data is growing exponentially, with increasing demand for instant data access and faster response times. Third, data needs to be made available to everyone all the time and without the need for technical expertise or any involvement of IT. And fourth, effective data management requires collaboration of data engineers, data scientists, business analysts, and operational data consumers. As an architectural paradigm, data mesh holds immense promise in powering analytics at scale by rapidly providing access to fast growing distributed domain sets, particularly in the case of consumption scenarios such as analytics, machine learning, or development and deployment of data centric applications, and a lot more. At its core, data mesh seeks to address the shortcomings associated with traditional platform architecture that resulted in the creation of centralized data lakes or warehouses. In sharp contrast to monolithic infrastructures for data handling, where the consumption, storage, processing, and the output of data is limited to a central data lake, a data mesh supports the distribution of data into specific domains. The data as a product approach allows the owners of different domains to handle their own data pipelines independently. The tissues interlinking these domains and the data assets associated with them serve as a layer of interoperability that maintains a uniform standard of syntax and data. In a sense, different pockets of data are interwoven and held together by a mesh. Hence the name data mesh. Data mesh is a mindset shift where you go from centralized ownership to decentralized ownership. You go from pipelines as first class concern to domain data as a first class concern. You go from data as a byproduct to data as a product. You go from a siloed data engineering team to cross functional domain data teams. And you go from a centralized data lake or a warehouse to an ecosystem of data products.